Hello, this is a video tour of a creative image editor, an app called Sift. Um, and Sift, what it does on a basic level, it takes an image and splits it up into layers. So this is the original image of David Bowie. And then it splits it into 16 layers and uses an additive blending mode to render those layers on top of each other. Then you can use the controls to move those layers around and you get these interesting interference effects, and it almost looks like a weird kind of lo-fi attempted 3D that I thought was cool. So how this started out, I was looking at waves in the ocean and thinking if I could do a wave effect on pixels. I've done several experimental image editors and gotten really used to thinking about pixels or images as a grid of pixels and sort of moving those pixels around, flowing them around, looping them. So a static image becomes has these pixel flows within it. And I was trying to think if I could do a wave effect on an image. And I decided I needed depth to be able to do that. So not just the grid, but I needed to extend downwards in order to have different layers of the image is what I was interested in, was different layers flowing at different rates and maybe coming over on top. So to do that, I figured it was possible. So each pixel has red, green, blue values, a kind of triplet of red, green, blue values, like 10 red, 10 green, 20 blue. That's how it makes up the color. And I thought I could use those values to decide on the depth for each pixel. So sort of extend it down lower, deeper if it had a higher value. And I sort of had a plan for that, and then eventually Sift is the result of that plan. I never got to the wave effect, but I did get really interested in the depth and how that all works out. So to get it to work, the two important things were figuring out how to slice it up on those values, and also then getting the blending mode, which is actually just telling the computer what blending mode, but it's interesting why it works. So to slice it up, I mean, originally I just thought I'll stack the images as high as the color value is. So if there was just one color value, if it was color value 200, then I would just stack 200 pixels of that color. There's actually 3 values because it's RGB. So I had to figure out that, and what I ended up doing was putting the brightest combo on top. So if you had a pixel that was 10, 4, 2 for each red, green, and blue value, then I'd first use up all the colors where each value we'll simplify it, we'll start with 1. So 10, 4, 2, I'd do 2 1, 1, 1s stacked on each other, and that gets through the 2, the minimum number of those values, and then I'd go to the next minimum, it's 4, and add 2 more, that's just 1, 1, 0. And then if there's 10, then I need 6 more to get those last red values in there. So it'd be 6 more, 1, 0, 0. And it's a little difficult to explain, but the end effect, you can see it on here. So the top is the more white values of this face, and then coming off to the side, so that side, you get this kind of color exhaust. I like to think of it as, you can see the red from the face fading out, and that's because the other color values have all been exhausted there. And then the black kind of just shoots through the whole thing because it's kind of on it is on every layer. You have those black values. So that was the depth. But in order to get that to work, I needed the pixel stacks. I needed, on a math level, I needed the values to be added to each other. And that would make the stack work pretty immediately. So there's a blending mode to do that. In Canvas, it's called lighter, but it's additive blending. And so I got the slices working and flipped that on, wasn't really sure what to expect. And this is pretty much what it was. I'm gonna switch images. Like, a point of this is you can switch images. Let's go to Akira, where you get this light box effect that I think is neat. So that worked. There's, on the app itself, there's this image. This is additive blending, so red and green and blue make white. Blue and green make cyan. Red and green make yellow. Stuff like that. So I kind of remembered this is true, but this is how your eyes actually work with light. It's not generally how computers do blending modes, but it is how your eyes, and I remember in grade school or middle school, whenever they teach you it, thinking that it's very weird because the highest RGB value is 255, 255, 255 is white, where sometimes, because we're used to drawing on white paper, I guess, you think of dark as being a higher value than light. And that's, same reason as why the background of this is black. So I had some idea that was true, but it's been fun to play with this and get used to those effects and then think about what this reminds me of. I think it reminds me of like projectors. Maybe I've seen some art where multiple projectors are projecting over each other. And then it makes total sense that that's what this reminds me of, because it is kind of, I think it is the same effect of how additive light works. So that is the rundown on those. And then the kind of technical aspects. So this is in HTML, Canvas, and JavaScript. When I was thinking about earlier, I wanted to do it in 3JS, like a 3D version, where you could actually zoom in. You can zoom in on this, but it's a little different, although it looks cool in its own way. And you would maybe see the gaps in between pixels. So you'd zoom out, almost be like a microscope going in, like in some science video. You'd zoom out and you'd see the regular image. This isn't quite regular, but, and then you'd zoom in and you'd see those gaps in between the pixels, and the pixels would shift and you'd get the interference patterns that you ultimately see. So I started there and I got the additive blending worked, but just ran into performance stuff in terms of, I knew I was gonna have to like bin and simplify, so I wasn't gonna render every pixel in like the full value, but even trying to simplify it was too much for performance. And I'm used 3 a fair amount, but I'm sure there's ways to do it in 3. I'm not actually sure if the math of like zooming in, if you could get, I think you could get the perspective to work. So there's a point where it's seamless and a point where it's zoomed in, but you might have to do some weird cam work. So I went back to Canvas, just sort of to try it out, and I think this idea had been forming in how to do it. So Canvas, it was not guaranteed that performance was going to work out. Part of it is doing 16 layers, so instead of 256 colors, it kind of bins them into bins of 16, and that helps. So the 16 layers, and you can see, I mean, it's basically, it is a posterize effect. Well, it's not quite a posterize effect, similar to a posterize effect on the original image. So you lose some colors. I think that's fine for the 16 layers. And then as you get out, it does those interference things. But to do it in Canvas, so what's happening is I split all the layers. I do all those calculations, which are pixel by pixel, like sort of doing that depth thing I was talking about. And I make the 16 layers into, they're canvases that aren't rendered on the thing, but they're, I guess, in the memory. And then what Canvas is good at doing, I have learned, is just drawing an image from one canvas to another. So each step where it's changing the offset, it's just re-render. It's just taking each of those, draw 16 times, top of each other. The blend mode does the rest, and that gets you pretty good performance. So this is 16 layers. You can change the layers. So that's double at 32, and I capped it at 64, which does get you, like, it's a nice effect. It slows down. This is even more slowed down because I'm running recording as well, but excuse me, you can see it go through, and you can also go less, which maybe gives you more of an idea of how it works. So that's just 4 layers moving around. That's the main run through I wanted to go through. Happy to talk to anybody about this. I guess just larger big picture stuff. This was a fun one. I'm in the middle of a larger constraint systems project that requires a lot of debugging and is taking a long time. So I took a break to do this. And I was pretty happy, like it went pretty smoothly in terms of, let's put a different image in. In terms of thinking of the idea, trying it out. It wasn't exactly what I didn't have a clear idea what I thought it would be, but it had this nice collaborative feeling with the computer of, I wonder what this will look like. I think it'll look cool. Oh, that is pretty interesting. And I don't know, that was just fun. That's my face. Oh yeah, I don't have this set up, but it also has kind of a weird effect on text. These are fast forward projects. So you almost get a 3D because the text is black, so it shoots through all those layers. Yeah, so I was happy with that project, how it gone. Future steps, sort of through suggestions from Twitter, I want to try this with video frames. So actually adding a temporal dimension to it and stacking frames across time with the additive blending mode. I'll have to change the slicing a little bit, but I think I know how to do that. And I definitely at least want to see what that looks like. I'm not totally sure. I have to get like the main thing, maybe getting like the frame set up, getting the right frames to do that. I'm probably going to try that and definitely learn something about additive blending. I think that'll probably come back someday. I'll do something else with it. And then the larger goals of all the constraint systems projects, so the image ones, it's definitely to get familiar with images as a grid of pixels, like really get comfortable with that and how they're stored on the computer, and try and go with the grain of how they're used on the computer, what the computer can do, and see what comes out of that. And I was really happy with how that turned out in this instance. I feel like it's a sign it's going in the right direction. Yeah, so that is that. So this is one of many experiments on constraint systems you should definitely check out. Thanks for watching.